Hello friends. So in the previous video, we had seen the projection of two lines which were inclined to one of the planes and parallel to the other plane. Now we are going to change this condition further and introduce a new topic of side elevation or side view. Now in this case, I have changed the representation also. Now there is a line AB which is inclined to both the vertical plane and horizontal plane. The only difference is that now we have introduced another plane which we would like to use to understand the condition. Till now we were using a horizontal plane HP and a vertical plane VP. Now we have another vertical plane which is on the side. So imagine these are three faces of a box. We have this vertical face here, we have another vertical face here, and we have this horizontal face at the bottom. Now this line I have encased as a hypotenuse of a square or a rectangle, whichever way it will depend on the angle. So in this case what we will do is we will make it as a square. So this is 45 degree, 45 degree. I have encased this line AB in a square, and this line is inclined to the vertical plane by 45 degree. It is inclined to the horizontal plane by 45 degree. And if I encase this line AB by a square, this square is parallel to the vertical plane on this side. For my representation, what we will do now is we are opening up the side plane to make it flat in line with the vertical plane. So now the vertical plane and the vertical plane on side are in one plane itself. And we will understand the method of finding the plan and elevation through projection. Since it is inclined to both vertical plane and horizontal plane, if I see from the top, I will not see the true length of line AB. What I will see will be this length, which is not equal to this length. If I was to see the front view projecting on the vertical plane, I would see from this point to this point, they will get projected on the vertical plane. Here also I will not get the true length of the line AB. Therefore, the first thing that I have to do is to project the line on the side plane and then work my way backwards to find its front view on the vertical plane and top view on the horizontal plane. Let us see how we do it. This part of the drawing is the side vertical plane. Let me make a reference in a red line. So this red line is actually, in a way, if for our understanding, defining this line, the meeting of the vertical plane and the side plane. So we are looking from the side, we are looking from this direction. So this line is actually representing this line, although we have opened it up. So if I was to project point B onto this plane and point A onto this plane, I will get the true length of this line. Now let us understand the condition of line AB with reference to the vertical plane on the side. It is 10 mm away from the vertical plane, or it is 10 mm away from the vertical plane. After 10 mm from the vertical plane is touching the horizontal plane. This is point A. From point A, I take a reference line at 45 degree. So this is the 45 degree that we are representing here. On this line at 45 degree, I measure the distance of 30 mm. So on this line of 45 degree, from point 8, I measure a distance of 30 mm, and this gives me line AB on the side vertical plane. This is the line AB on the side vertical plane. Now, there are two concepts of transferring the projection from the side plane onto the horizontal plane. How is it happening? I drop down point B and then turn it around at 90 degree to get the projection from here. That is what we will do in this red line. This red line is the turning point of vertical plane and the vertical plane on side. So let us understand the technique that how we take the projections from the side elevation to the plan or from plan to the side elevation. Both ways. We have this line of a certain dimension. Let us call it A. I take down from the two ends of the line the projections down to this line at 45 degree. Wherever this first point cuts the 45 degree line, I took horizontal line to the horizontal plane. Same I did with this line. It came down, cut this point, and then it was taken on this direction. Since it is at 45 degree, this length A will be transferred as A out here. If this angle is reduced by 45, I will get a smaller line, and if it is increased by the 45 degree, then I'll get a bigger line which will be wrong. So for example, this second line is less than 45 degree, and when I dropped the line here, it touched the angle line here. I turned it here, I brought this down, it cut the second line here, I brought it here. Now B is smaller than A. So this is a wrong transfer. Let us understand how we will transfer the projections from the side elevation to the plan or from plan to the side elevation. In this case, this straight line around the XY line gives us the fold between the vertical plane and the side vertical plane. There is this line with length A. I brought down the projection to the XY line. From the XY line, I brought them down at 45 degree. Wherever these two projections cut this red line, I again turn them to make them horizontal. By doing this, the dimension A gets transferred same as dimension A. If I was to take this at an angle other than 45 degree, so for example, we have now reduced this as less than 45 degree. So when the line touches XY line, it turns on this direction. When this point touches the XY line, it goes parallel to this, and then I take the projection flat. B is less than A, so it is to be taken at 45 degree, or this has to be taken at 45 degree. This is the concept that we will use now to get our projections. Since the point is touching the XY line, from here I had projected this at 45 degree, and as soon as it touched the red line, I turned it around parallel to the XY line, and this reference line was achieved. From the point B, what we had done, we had first dropped down the line and then we had turned it on this side. That is what we will do here also. So here what we did, from the point B, we dropped down the line on the XY line. From there, I took a 45 degree angle, and from there I again turned this reference line as a horizontal line, and it went further. This distance between this line and this line is the distance as we will see from the top. From point B, we came down here. Let me take a random point out here, which is my point B. From B, I drew a perpendicular line towards the XY line. Wherever it cut this blue line, that gave me point A. And this now is the top view of the line AB. From here, then I took a projection straight on the vertical plane. So it is almost going like so. This line from this projection is this line. It travels from here to here. It travels from here to here. From this point where we have this red line, it turns around. It travels from here to here. It travels from here to here. Wherever it meets the projection from the top view, that is, wherever it meets the projection from the top view, I get point B. And wherever this projection from the base meets the XY line, I get point A. And joining point A and B, I get my line AB in front view. So this is the front view, this is the top view, and a new thing now that we have introduced is this view is the left side view. Now if you notice, the left side view is on the right hand side. So when we will see from the left side, the view will be projected on this side. So the left side view is coming here. So this is the XY line. This is the line of fold which we have brought. We'll do the same exercise again. On XY line, at a distance of 10 mm, we identify point A. So I took a reference line at 45 degree from the XY line from point A. I measured a distance of 30 mm, identified point B. Joining A and B gave me the side elevation of the line AB. Till now the technique is the same as we had done here. Now the change that has happened is that in this case we had dropped the line, the projection onto the XY plane and then taken a 45 degree angle. So whatever dimension we have between here, because of this 45 degree angle, we will get the same dimension here also. Now instead of taking it like this, we will make this line of fold at 45 degree. This is a change that has happened. Out here we had taken projection down. It touched XY line, we took it at 45 degree and then we turned it around. In this case, this projection will go down right till the 45 degree line and then it will turn around. At a random point, we identified point B. From point B, I took a line up perpendicular to the XY line. From the point A, we had taken from XY line a 45 degree line, and whenever it touched the fold, then we took a horizontal line. In this case, what we will do, we'll drop a line from point A to this fold line and then turn it around. Wherever this line meets this perpendicular line, it will identify point A. And this is my line AB in top view. Then I projected this line up and this is the same line as we had here. This is taken straight. So I took projection from this side and I projected these lines upwards. Wherever these two met, I got point B. Point A is on XY line. I take projection and wherever it cuts the perpendicular line, I got point A. And by joining point A and B, I got the front view of the line AB.